Today we're going to talk about translations and reflections. And in terms of our first quiz, it's just going to be the translations. So as we're going through the notes, I'll point out which ones they are. But the whole unit name is called transformations. So we're going to be doing different things to a shape, an image, a figure. And what happens when we're doing transformations is that we create a new figure somewhere else. So we might slide it, which is a translation, which is what we're going to have on our quiz tomorrow. We might move it right, we might move it left, we might move it up, we might move it down, or a combination of those. We can flip this, which is called a reflection. We can turn a figure, which is a rotation. And then we can enlarge it or reduce it, which is called a dilation. You usually think of dilations like when you go to the eye doctor and you get your eyes dilated, your pupils get really big. But for dilation, not only can they get bigger, but they can also get smaller. But for this unit, we're going to stick with rigid motions. The rigid motion is a transformation that doesn't change the size or the shape of the figure. So the figure stays exactly the same. It changes its location somehow. So the ones that can change our location are a translation, which is the slide. We move it again, up, down, right, and left. A reflection, which is flipping it somehow. And then the third one is the rotation. Again, a rigid motion, it doesn't change the size or the shape. So the rotation, the turns, isn't going to change the size or the shape. And again, a translation. It's a type of transformation. In a translation, the geometric figure will shift or slide either left, right, up, or down. That's all it does. In any transformation, the original figure is called the pre-image. And then once we perform the transformation, then the new figure is just called the image. And what we have over here to the right is we have a figure. The diagram at the right shows a translation in coordinate plane. Again, translation is sliding this graph. It's moving it right, left, up, or down. In this case, as you can see, the triangle is shifted left 5. So here, if we look at A and we count 1, 2, 3, if I can count 4, 5, and then we're going to go up 2. 1, 2. So the board's already a little bit disoriented, but if you count on your paper, hopefully it'll show okay. Maybe on the B I have a better luck. 1, 2, 3, 4, 5, up, 1, 2. That one I did better with. C, 1, 2, 3, 4, 5, up, 2. Is what we're counting. So what we do when we write this in that format to illustrate that we're moving our graph 5 units left and up 2 units, well, because we're moving 5 units left, we say x minus 5 and y plus 2. And if I get a little bit more specific here, it's x, y arrow, and I usually say maps to. X, y arrow maps to x minus 5, and again, the minus 5 means that we're going to move left because x moves left or right. And the y plus 2, the plus 2 moves us up because y goes up or down on the graph. And that's what we're looking at for our first quiz of this unit, which goes with our first example here. Graph the image of the figures graphed below using the given transformation. And what it says here is, it says the same thing almost that we just wrote. This one says x, y arrow maps to x plus 5, comma, y minus 2. The plus 5 means that we're going to move this graph right 5. And the minus 2 attached to the y means that we're going to move it down 2. You may want to use colored pencils to do this, although this one works out just fine since we're only doing one image on it. But if we start at A and we start counting, 1, 2, 3, 4, 5, 1, 2. Here's our new A point, and we illustrate that by saying A, and it looks like a 1, A prime. It's just a tick mark. We can do C. Starting at C, we're going to count 1, 2, 3, 4, 5, and down 2. Here's our new C, which I'm going to label C prime. And we'll do the same thing to B. 5 right, starting at B. 1, 2, 3, 4, 5, and down 2. 1, 2. Here's our new B, which we'll identify as B prime. Again, this transformation doesn't change anything about the triangle except its location. That's all that it changed. So if we know how to read the format, when we get to letter B, it's going to be the same thing. This one says x, y maps to x minus 3, y plus 1. Well, minus 3 on the x, or attached to the x, means that we're going to go left 3. Plus 1 attached to the y means that we're going to go up 1. And that's what we're going to do for all 3 of these points in our triangle. Starting with Q, if we go left 3, 1, 1, 2, 3, up 1. Here's our new value of Q. We're going to call it Q prime. From L, left 3, up 1. Here's our new value of L. And then 1, 2, 3, up 1. U. 1, 2, 3, up 1. Again, when we translate, which means we shift this or slide that triangle, nothing about the triangle changes except its location. Another kind of rigid motion is called a reflection. And a reflection is a type of transformation in which a geometric figure is flipped over what's called a line of reflection. So perhaps the hardest part of this is going to be, can you graph the line that it's reflecting over? But in a reflection, a pre-image and an image have opposite orientations, and each vertex of the image is the same distance from the line of reflection as the pre-image. So in words, that probably doesn't make as much sense as it will when we see an illustration of this in our first example here. It says, graph the image of the following figures using the given transformations. Well, we're going to first of all reflect over the x-axis. So we've got a nice label here, and I'm going to put a solid red line, the best I can, which is weak at best, there on that axis. And again, that's where you might want to use a highlighter or a colored pencil. we're going to reflect this over the x-axis. And as we draw this figure here, I'm going to start with point K. Point K is one space away from the red line. So one space from the red line on the other side is going to be our new value of K. Point L is 1, 2, 3 spaces away from our red line. So on the other side of the red line, we're going to count 1, 2, 3. Here's our new L. Point M is 5 spaces away from the red line. So on the other side of the graph, the other side of the red line, we're going to count 5 spaces. And there's our M prime. And finally, N is 3 spaces away from the red line. So 3 spaces away from the red line. On the other side of it, 1, 2, 3. Here's our new N. Here's our new figure. Reflective of the line y equals 1. So again, we need to be able to draw the line y equals 1. And what we ultimately need to know is that the line y equals 1 is a horizontal line. It's that line right there. And once we can get that, by the way, we crossed the y-axis. That's why it's y equals 1. We crossed it at 1. But as we look at this, remember, we're going to be counting the same distance away from that red line. If we start with letter S, it's 1 space away from the red line. So on the other side of that, we're going to draw a point that's 1 space away from the red line. That's our new S. T is 1 space away from the red line. So on the other side of the red line, 1 space away. There's our new T. U is 1, 2, 3 spaces away from the red line. So on the other side, we're going to count 1, 2, 3 spaces away from the red line. And V is also 1, 2, 3 spaces from the red line. So on the other side, 1, 2, 3 spaces from the red line is our new V. And hopefully your picture is a little bit better than mine from the disorientation. We reflected over the line y equals 1. Sometimes I find that getting that line y equals 1 is the hardest part. Letter C, reflect over the line x equals -2. Well, if y equals is a horizontal line, x equals must be a vertical line. It's going to be this line right here. I'm going to reflect over it. The nice part on this particular problem is because line or point C is on the red line, it's not going to move. And point B is on the red line, it's not going to move. So we only have to reflect point D and point A. I'll start with A, which is 1, 2 spaces from the red line. So on the other side, 1, 2 spaces from the red line. D, point D is 1, 2, 3 spaces from the red line. So on the other side, 1, 2, 3 spaces from the red line. And it might have been nice if I labeled my points a little bit better here. But this is A prime. This is D prime. And then here, this is our B prime and our C prime. The last type of rigid motion is, oh, well, we're still on reflecting actually. An important type of transformation that's often asked on the OST is reflecting over the line y equals x. So first of all, we need to know where the line y equals x is. And it actually goes from the bottom left of the graph to the upper right, so the bottom left to the upper right and through the origin. And I oftentimes, when I draw it with a dotted line. And I think that it might be useful if you used a ruler, just because of how we're going to count to get this particular figure reflected over the line y equals x. I'll start with the letter S here. And what we're going to do is we're going to count down to the red line from our point S. So I'm going to count 1, 2, 3, 4, 5, 6, 7. And then, since we went down 7, we're going to go 7 spaces to the right. That'll put us over there on the other side of the red line. 1, 2, 3, 4, 5, 6, 7. This is our new S. We're going to do that with a T. Count down. 1, 2, 3, 4, 5. We put 5 spaces down to get to our red line. So to get on the other side, we're going to go 1, 2, 3, 4, 5. Here's our new T. If we look at U, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here's our new U. You're forming a right angle when we do these. And one more time. From B, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our new figure. Let's try another one. Here we've got a triangle, but we're going to reflect this over the line y equals x. Once again, I'm going to start at the bottom left, going up to the top right, through the origin, and I tend to draw this as a dotted line. And I mostly draw it as a dotted line. I want it to be precise, but I don't use a ruler oftentimes. And if you're not using a ruler, that might be helpful for you. But when we look at this, remember that our goal is to get to the other side. So when we draw our picture here, what's going to happen is D, I'll start here at D. Is 1, 2 from the red line. So then I need to get to the other side, so I'm going to go 1, 2 left. There's our new D. If we go over here to E, 1, 2, 3 to the red line. So 1, 2, 3 to the red line. Here's our new E. And here's F. We're going to go 1, 2, 3 to the red line. So on the other side, 1, 2, 3 to the red line. There's our new F. Remember with transformations, we're not changing the size, we're not changing the shape. We are moving the figure somehow. And there's our new figure. Colored pencils, maybe you help. I'm just suggesting. As we get close to finishing here, if we reflect this line, reflect this square, it looks like, over the line y equals x. Y equals x. Lower left, upper right, 2, 0, 0. Is here. And I'm going to count. I'll start with W. 1, 2 spaces to the red line. So 1, 2 spaces to our new W. Kind of left. If we do V, 1, 2, 3, 4, 5 spaces to the red line. So we're going to go 1, 2, 3, 4, 5. Here's our new V. T is 1, 2, 3, 4, 5 spaces to the red line. 1, 2, 3, 4, 5 to our new T. And you can probably guess where the new U is, but to the red line. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's our new U. And here's our square. Transformed. The thing is, it says, example 4, it says, write the coordinates of the pre-image and the image. So if we look at, I wish I wouldn't have written in black, but oh well. If we look at our original here, the pre-image, which is kind of down here and to the right, our ordered pairs, oh shoot, it's for 3D. Let's do this one since we can see it right now. Anyway, it doesn't matter. So W is 1, negative 1. And V is 4, negative 1. U is 4, negative 4. And T is 1, negative 4. If we look at that, so there's the pre-image. Right underneath it, I'm going to write down the image. Make it a little bit better since the board is kind of disoriented and I'm running out of space. But if we look at the image then, so that's going to be our new black, which I'm going to put with green points here. There's our image. And we started with W first, and our value is going to be negative 1, 1. That's where the order pair is. And V is negative 1, 4. And U is negative 4, 4. And the last one, T, is negative 4, 1. Do you see any relationship between those points? And hopefully you do. What I see here is that we had 1, negative 1. It became negative 1, 1. Looks like the signs changed. 4, oh no, looks like they flipped places. 4, negative 1 became negative 4. The points switched. 4, negative 4 became negative 4, 4. doesn't show up very well in that one. It probably showed up better in letter B, and then 1, -4 became -4, 1. All that you have to do for reflecting a figure over the line y equals x is to reverse the points.